This is going to be an example of creating a tool fixture. We have a block. This is the size block you're going to create, and you're going to split it to a surface. So somehow I created a surface and made that solid go up to that surface. I'll explain how I did that. If you want to give it a shot, you can. It will be some things I haven't shown, so you can try it and see what you were able to come up with, and then come back to this video so you can get the explanation here of what a tool fixture is. In case you're not familiar with it, go ahead and pause this video though and give it a shot. So what I have here is something we've done a lot in production. We would make a tool fixture to hold an engineering part in place so that we can machine it. So I worked out in the door and doorway lining groups. I worked in the Everett NC program group, and we would have panels that we have to machine. And what we did was we took the engineering surface that represented the outside skin. So let's say this is a door. We took the engineering surface that represented the door, and we would cut it to a block of aluminum or whatever, some type of block to form that same shape. And we would vacuum suction the part down or clamp the part down so that we can machine it. So in this example, this would be more like an NC mill fixture. We have vacuum lines holding this part in place. I did a lot of the interior parts, the Nomex panels, sidewalls, ceiling panels, overhead storage bins, stuff like that, machine those types of things using a 5-axis machine. So in order to create the tool fixture, we have to create a solid and split it to that surface that represents the engineering part. So in this example, what I did was I created a new part body called tool fixture. So I'll just go ahead and delete this out. And then I created a rectangle that went up to that. But I'll delete it out and show you how I did it. And I'll even delete out this extrude. So I used that same sketch that I created in the construction geometry. And the block had to be 6 inches wide. So we're going to go to, I'm currently in the part design workbench. I got to make sure I'm in generative, wireframe, and surfacing to create that extruded surface. So now that I can see I'm in the proper workbench, generative, wireframe, and surfacing, I will make the tool fixture the in-work object to make sure it knows I want to build a surface in there. I'm going to use the extrude, the first one I showed you. Grab that profile as my spline, and I just went 8 inches long. And I select OK. Alright, and then I gotta make the solid. So I'm in wireframe and surfacing. Wireframe and surfacing creates construction geometry. Construction geometry is points, lines, curves, planes, surfaces, faces, OMLs, IMLs. All that stuff that's not a solid is in the construction geometry, and it's all built in generative wireframe and surfacing or generative shape design. So I gotta switch to part design to make a solid. But before I can make a solid, I need a sketch. But I want to be in the tool fixture in work object. So geometrical sets are making for making surfaces, and tool fixture, this part body, is made for creating solids, which is anything in part design. So with that underlined, I can slide under here, sneak under here, and grab that plane and work on that bottom plane, and I'll hit this sketch. So when I create this rectangle, I want to make sure that it's inside the actual part. So I'll come like here maybe, and I'll come over to here. Okay, so that's as big as it's going to be. I will go ahead and you got to make sure that this rectangle doesn't go beyond this surface, because the surface is going to be used to cut the solid, and if the surface doesn't go all the way through this profile, it won't cut all the way through the solid and it won't know what to do. So we'll go ahead and exit the sketch, and I'll create a pad. So we'll go to model. I'm going to go to the pad feature, and for a type, I'm not going to key in a length or anything. I want to go to a surface. So I'm going to pick the surface and pick the surface I created and select OK. And that is how I created my tool fixture. Okay, so in real life in production, after I've created my tool fixture, I would hide the construction geometry. And then the next step would be to put on vacuum lines and to seal grooves. I teach that also in the engineering tool design class, the ENGT 196. I teach tool design, and we do make an NC mill fixture and show you the process. The other reason why you should take tool design, even if you didn't want to do tool design, is I teach product structure in there, and that's really when you start actually using CATIA is learning your product structure. So you would get a 2-for-1 in the ENGT 196 class, tool design, creating tool fixtures, as well as working on the product structure, the specification tree.